So this week, you may have noticed, and it had nothing to do with the circumstances, that you don't have a lab. You've got, well, okay, so it's mostly not a lab. You will probably have to pop open a VM or two to be able to get through this week's stuff, right? I mean, in certain questions, like this particular question can be answered just straight out of the notes. I think it's some of the, yeah. Um, Yeah, most of these questions can be answered with the notes, but I think to double check yourself on some of this stuff, you may want to pop open a VM and actually run through some of the commands to figure out whether or not you are right in the question. So the reason that I'm kind of harping on that is because since there's only one assignment this week, that means that this assignment is a little more important than the other, since it'll since without a lab, it'll weigh a little heavier. So anyway, let's dive in. This stuff is pretty much surface level stuff. You're not going to necessarily be, well, you're certainly not going to lab on any of this stuff yet. The kernel module stuff, you really don't do this often. If you are on the bleeding edge, if your company requires that you use hardware or software that is way ahead of the curve in terms of what most Linuxes support, you're probably already not going to be getting support out of a contract or something like that anyway. So this stuff is pretty fringe. However, you got to know about it. So kernel modules are pretty much like the device manager of Windows, and we're going to get into storage as well. Now, this stuff you'll need to know, but this stuff will not. You won't come up to anything extremely important until next week. We're going to dive into more storage next week as we go on through. So anyway, kernel modules. Kernel modules are really just a short way of describing a way to tell the kernel about hardware it doesn't already know about. So that really kind of just means that, let's say that you're running on an older version of Debian or an older version of CentOS, and it does not have a kernel new enough to know about NVMe drives. So NVMe, in this particular case, NVMe is really the newer standard of SSDs that plug into your motherboard like RAM. And you can use them, obviously, like an SSD of any other type, right? A SATA type SSD or something like that. But some kernels just do not know about them. I think it was like kernel 4.12 that learned about NVMe. So sometimes you will just be in a situation where you do not have it. Debian 9, I think, is stuck on kernel 4.9, so it would not know about NVMe drives. You would have to add a kernel module. So we're going to describe kind of how that, how you would actually do that. So first things first, LSMod. The idea with LSMod is that you should probably have an idea of the kernels that are or the modules that are loaded on your system in the first place and what that means. So if we do LSMod here, you can see that we're looking at on the left-hand side, all of the kernel modules that are loaded or not loaded on the system. So they may be referenced or something like that, where it might be something that is, well, pretty much everything here is required by the system in some way, somehow, but the system may not have loaded those kernel modules. So on the left-hand side are the kernel modules themselves. In the middle, you see a bunch of numbers. Those are the size of the kernel module, so in bytes. So if you look at the very top of that screen, you see sound core 16384. That's 16,000 bytes, so 16 kilobytes. And it is used by one other thing. So the column next to it, you see a 1. It's used by one thing, and that is the kernel module sound, S&D. So that's really what that means. The kernel module, the size of the kernel module, the how many times that kernel module is being called up, and by what. So each of those things is fairly important to a system. So you can figure out the same kind of stuff on a Windows box by going to Device Manager, right? That's really what Device Manager is meant to show you, the types of devices that are on your system, and that's exactly what you're looking at right here. So on one of the systems that I was playing with, I don't guess. Nope. So there are no NVMe drives on the system, so therefore no module of NVMe. But I know that this version of Linux does support it, so it's just not showing up because there's nothing NVMe. So you can kind of see, like, that particular driver, if you wanted to go see it, see what it's about, see how you do it, all that kind of fun stuff, here is a download for it. But they remind you, right? It's all well and good to go get a driver and go add them to the system and then load them up and all of that kind of fun stuff. And I'll show you at least the commands to do that. But you don't need to. It's part of the kernel. So the easiest way to get a hold of new kernel modules that you know are going to be part of the Linux kernel, right? They're not in your kernel, but they're in a newer kernel, is to just go get the newer kernel. And a lot of times that really just means upgrading your system. So for Ubuntu, they do something called hardware enablement. So this basically means that newer kernels are backported to the long-term support release. So I'm running Linux Mint here because I'm on the Mac and it's just easier. I didn't want to install a whole new system for this, but it's based off of Ubuntu 18.04. And the thing about a lot of Linux distros is that you have to kind of figure out. If you're on CentOS, you're always on a long-term support release. If you're on Ubuntu, though, there are interim releases. What you want to do is head to ubuntu.com, and you'll see, when you go to downloads, you'll see this LTS thing, and then 19.10. So 19.10 is the most current, but this LTS is the one that you would get if you want long-term support. What that means is it's 5 years. Well, no one in their right mind, unless you have a very specific job in mind, and that job will never change. And that happens a lot, right? I mean, a web server can just truck along for 5 years without seeing many changes. That is totally a thing. But if you are getting or trying to be on the newer side of hardware, right? Like you have a server that supports NVMe drives, you're probably going to want a newer kernel. So what Ubuntu does is they will do what's called backporting. So every interim release, they take the newer kernel in here and give it to the long-term support releases. You do not have to take that newer kernel, right? So with new features do come some flaws. So there are situations where you would just want to reject that newer kernel. And that'll really just mean getting the very first release of the, I'm pointing at the desktop, I mean here on the server. You would just want to get the original release of 18.04 and then just stay updated. If you get any of the newer releases, so there's 18.04, and then there's 18.04.1, .2, .3, and I think we're on .4 now. If you get any of those releases, it will come with the newest kernel, and it will keep you on the newest kernel. So when 20.04 comes out, you're going to see a backported kernel here. You're going to see 5.4 come back over here. If you do not do that, then the way to find out your kernel is uname. Well, if you just do uname by itself, it'll give you, that you are running on Linux. R will ask for the kernel version, and it'll give you 4.15.0-54. So that 54 is there have been 54 updates to that particular kernel, security-wise or whatever. And this stuff is not necessarily going to be on any test, just that you're going to run into some of this stuff, and you need to know how to figure out what your kernel is, and you need to know that distributions deal with their kernel differently. So anyway, long story short, if you're on Ubuntu, you just want to take that hardware enablement kernel. So the hardest part about that is knowing what it's called, hardware enablement. So Ubuntu 18.04, HWE, or a hardware enablement. So there's pretty much always a wiki page where you can go and figure out how to get the newest one. It's fine to go to these blog posts or whatever, but, I mean, come on, ubuntu.com. There is an official way to do this, so do that. And it'll tell you, right, if you're on 1804, which is the current long-term support on a server, you'll run that command, right? So install all recommended packages that come with the Linux-generic-hardware enablement-1804. And that'll put you on the newest, latest, and greatest kernel that Ubuntu supports. And it'll keep you on a supported kernel. That's the magic of all of this. So it'll continue upgrading your kernel as the older kernels become obsolete. So anyway, that'll keep you on the new stuff, right? Like if you need NVMe and you don't want to have to insert kernel modules, just stay on the newest kernel, and that comes out, at least on Ubuntu, every 6 months. Now on CentOS, you're kind of up a creek because they tend to not upgrade their kernel between releases. So you just have to wait till CentOS 8. Now, that is probably not the best thing to do, or if you're on the latest and greatest hardware. So what do? You just don't grab the latest and greatest hardware until CentOS or Red Hat actually support it. Otherwise, you are outside of a lot of the support that you would be buying from Red Hat. So this right here is kind of a really good example of why do I want to go with CentOS or why do I want to go with Ubuntu? And a lot of times that just boils down to hardware support. Are you using newer stuff? You probably want Ubuntu if CentOS doesn't support it. If you're not using newer stuff and stability is important to you, then stick with CentOS. Anyway, so if you find one of these particular modules and it's misbehaving, right? USB HID, human interface devices. That'll typically be your mice and keyboards and things like that. Well, you've unplugged and replugged, and for some reason those devices are still misbehaving. You can use rmmod to essentially disable that module. And really all you need is, and I'm not going to do it because I don't want to break anything, but rmmod, and you would type in USB HID. HID. There we go. Obviously, you'll need a sudo for that. It's a admin type command. But anyway, so run that. It'll unload that kernel module. So this, at least as far as the Ubuntu USB human interface devices go, it's like as if you were doing a reboot. You don't reboot the whole system. You just, that one particular module is what you want to deal with, right? So you can do it that way. And the opposite of that, to put it back in, is insmod. So insmod and that same module, USB HID. However, and this is kind of out of order, modprobe does all this. So this is, I won't really say the old way or deprecated way of doing things or anything, but modprobe does all of the things that you want to do. So a lot of times you will mostly see the modprobe command. So sudo modprobe -r for remove USB HID. That will remove from memory the current USB HID kernel module. And to bring it back, just do the same thing, but without R. So modprobe USB HID will enable or load into RAM the USB HID kernel module. And this goes with any kernel module that shows up on this list up here. Right? If you want to do the network adapter, E1000, there you go. And it'll be available for you somewhere up there. Something is using it because I have network. Anyway, kernel modules. Typically, on a Windows machine, you don't have to really care where the modules are. You just like download a new driver and shove it in there. But in Linux, you tend to not get, well, at least as a person, you tend to not go out and download random drivers and install them onto your system. Those come with the kernel, and they are listed explicitly here in userlib modules. The kernel name, now this right here, kernel designation, this is, when I typed in uname r above, 4.15.0-54-generic, that'll be what goes here. So you'll see, 4.15.0-54-generic, right? That's what'll go there. And then inside the kernel directory, you'll find all of the modules that end in an extension of KO. I do not know what KO stands for. Usually I tend to find out what that means, but I never figured that one out. Anyway, Ubuntu stores them in a different spot. So CentOS and OpenSUSE, we'll put them here. And Ubuntu, we'll put them here. So the difference is USR. In CentOS and OpenSUSE, it is there. In Ubuntu, it is not. It is just in lib. In CentOS and OpenSUSE, it's in USR lib or user lib. So remember, I pronounce it user, but it's Unix system resources. Anyway, if you want to figure out dependencies, you can do one of a couple things. You can do, well, actually, no. One of one thing. Look at the modules.dep file. So modules.dep, dep for dependencies, you can find this file inside of the same kernel designation directory. So let's go here. I'm on an Ubuntu system, so modules, let's see, yep, 4.15.0 whatever, generic. Let's go in there, do an LSL, and you can see it there toward the middle, modules.dep. Now, this is a pretty big file. It's 552 kilobytes, which means it's pretty big. So if I cat this, it's just going to go on and on and on and on. So let me do let's just do a tail of modules.dep. And you can see down at the very bottom, kernel, ZFS, ZPIOS, ZPIOS.ko, this one here. So that is the kernel module. You see a colon, and then you see a list of additional modules. So ZPIOS.ko depends on, and I know you can't see my mouse, but just follow that line here. ZFS.ko, ZUnicode.ko, ZVAL.ko, ICP.ko, ZCommon.ko, ZNVPair.ko, and it looks like SPL.ko. All of those are required to load up the ZPIOS.ko. Why do I bring this up? It is important because if you decide you want to use insmod or insert module, then you have to know this. You will have to play a game of tag if you're loading up this module. So you do ZPIOS.ko, you do insmod ZPIOS.ko, and then it's going to come back with an error and say, hey, turns out you need all these other kernel modules first. So you got to go back and work backwards and start inserting modules one by one as needed to load up the ZPIOS.ko module. Or, here is why you want to use modprobe. Just do modprobe ZPIOS.ko, because modprobe will search this file, find every one of the module dependencies, and load those up too. So insmod is great, right? It will insert a module for you. Modprobe is better because you won't end up in this weird circular logic of, oh, well, I need this first. Oh, well, I need that next. Oh, well, I need that next. So be aware of a slight difference between those two. Insmod, you'll need to find all of the dependencies and load them up in order, or you can use modprobe, which will just kind of figure it out for you. And obviously, I'm a man of, let's say, malaise, so I would certainly be using modprobe pretty much every single time. However, understand, insmod may show up if you decide to take the Linux Plus test. All right. Let's see. Yep. And there's another example of it, the NVMe.ko. So here's the module you want to load. Here is the dependency and where it lives. Depmod is a command to update dependencies. However, you don't typically run this command. You can run this command. But that command will basically just research this modules.dep file and verify that there are no new dependencies that are required for any particular thing. So this happens automatically for you. Anytime you insert a new kernel, depmod is automatically run, and this file is automatically read. So most of the time, you're not running depmod for any reason, unless you are installing kernel modules manually. So that'll pretty much be never. Now, the last little bit, at least on this, is going to be the etc modprobe.conf command and the etc, or I'm not command, file, or the etc modprobe.d directory, which contains additional files. So I don't think I even have an etc modprobe.conf, but if I were to have that file, it would have configuration pertaining to the way that modprobe should work. So let me see. cd etc mod. Doesn't look like I've got one. Oh yeah, so yeah, I do not have this file, but it'll contain information about how modprobe should run. But what I do, or what I should have, a cd mod probe.d. Yep. So let's go in there. And one of the important, or the more important files that you can find in here is a blacklist file. So this blacklist.conf, which you can see right about here, is a file that will contain a list of kernel modules that should never be inserted into memory. So if you cat this file, you can see Garmin_GPS, BCM43XX, so anything in the 4300 series, Prism 54, I2C, I801, and you can see there's a comment. So these are all by default, and these are just modules that are already in the kernel that Ubuntu will blacklist for you because of some particular reason, right? So in this case, if you were to use this SND_PCSP, you'd get low quality just noise when being used for sound playback, causes hangs at desktop session start. So that's not anything that you actually want to be using. So Ubuntu blacklists it for you. If you want to use it, though, you can just remove it out of this file. If you want to add anything to this file, just add another line, type blacklist, space the module you want to blacklist. You can add a comment or not. I would recommend using a comment just in case anybody comes in after you. They can figure out why this particular module is actually blacklisted. Mod info will show information about any given module. So let's do lsmod, let's do mod info drm. Right? You can see the DRM module here is in use, and they'll tell you some information about it. Doesn't depend on anything if you look here. So yeah, that's what I was thinking earlier. This is the second way to look at dependencies if you need to. And just some general information. If you want to know what this kernel module is all about, where it lives, any of that stuff, here it is, right here. All right. So this stuff, I'm really not going to show a whole lot because there's not really much to show. Here, let's go there. But what I can show you is that a lot of these directories actually do exist, right? So you've seen a lot of this stuff so far. We've talked about a lot of these directories, but now we get to kind of get into the nitty-gritty of what these directories actually are, what they mean, how to get in and out of them, etc. So you've used the cd command enough that I assume you should be okay getting in and out of directories. I think a lot of times that really just requires some practice on figuring out how to move in and out, all that kind of fun stuff. A couple of shortcuts I could show you as well. But overall, look at this. It's the root of the entire file system. Everything lives in here. So no matter what file you're talking about, no matter where you are in the file system, there's going to be a slash at the very beginning of it because everything exists within the Linux file system. And that / is the beginning of it. So the top. Anyhow, inside of the root file system, you'll find all of these directories. Not every system has every directory, but you'll have most of these, if not all. So bin and sbin tend to contain low-level file system stuff. So yeah, like in Windows, think System32, syswow64, right? This is where the Windows software lives, the stuff that Windows requires to run. SBIN as well, but this tends to happen. This tends to have booting type software in it as well. Boot will contain grub and the kernel. Dev is mostly a symbolic directory. This contains things like devices, hard disks, TTYs, all of that fun stuff. So if we go into dev, you can see a listing of all of that. Right, everything's in a different color. Let's see, you can find dev. Oh, whoops. Let's do dev SD. There we go. So you can see SDA, SDA1, SDB. You can see that there are a couple of disks in here, one partition on one disk. Fun stuff, right? The TTYs that we could see above. Oops. Right, you can see all that. I think you can see, I don't know if there are any. It doesn't look like there are any, but you can find PTYs, your pseudo terminal. So if you were to launch a graphical terminal in Linux Mint or Ubuntu or anything else, you would see a PTY exist there. So none of those are actual files, but they look like files on Linux. And the old adage of everything on Linux is a file. That's really where that comes from. ETC contains configuration files. So you can think of this as like program data or app data on Windows. Home, where all of your user stuff is. Lib, where earlier on in the semester we were talking about libraries, the shared code. So if you were to install two browsers that are similar to each other, there's a good chance that there's software in lib that they both use. So they both link to libraries in lib. MNT and media tend to be pretty interchangeable. I think on Mint you have, or on Ubuntu you have both. Yeah, you have media and MNT here and here. And they're, like I said, used pretty interchangeably. This is just where you mount stuff. If you plug in a USB drive, it's probably going to be mounted in media. Opt tends to contain third-party applications. A good example of this is Packet Tracer. Packet Tracer will install itself into opt. Right? It's not a Linux thing, but it is software that runs on Linux. Cisco being a third party, therefore that's where they install their software. Proc, another one of those symbolic containers like dev. Proc will contain information about your system, so processor information, memory information, lots of fun stuff. Let's see, LSL proc. Yeah, scheduling. Oh, you'll also find, ooh, that's right. Let's see, pipe that to less. There, you can also see, look at all those numbers. One thing I want to show you about those numbers, let's see, 3802. So this line here, there's a 3802. If we do PSAUX, ooh, it's gone already. So there was a, oh, you know what? It may have actually been less. And I quit it. So 3804 is now. So anyway, what I'm getting at is that those particular numbers in the proc directory are actually processes. So if you were to delete one of those, you would be essentially killing a process. But, you know, typically we've talked about this before. You just use the kill command to do that with. So root. Yes, this is another name for this. That is the root of the file system. This is the root directory in the root of the file system. So this particular directory is root's home folder, right? Just like you have a home folder in home, root's home folder is here. /root. Try to get into it. You can't, right? Now, you can if you become root, obviously. Nothing in there. But that's the deal, right? TMP, don't ever put anything in there that you don't want to lose. TMP tends to, depending on the distribution, tends to get deleted every now and then, and that might be every reboot, that might be every 30 days, that might be whatever. You would need to check cron. We haven't talked much about cron just yet. I've mentioned it a few times, but we haven't really gotten into the nitty-gritty of it. We will soon. But check cron for when temp will get deleted. Cron is just a way to schedule tasks, right? And that might be on boot, that might be every day, might be something, right? USR, Unix System Resources. USR tends to contain different software that, pretty much just different software that any Linux distribution might use. A lot of times, there might even be links. But what there is, and I think the most important thing about USR is that you'll have a bin and you'll have an SBin. This is another place where a lot of different third-party software gets installed. So if it's not an opt, it's probably in user bin or user SBin. And same with lib. There is a user lib as well. And it depends on the distribution. All right, barring any more loud noises, let's get this done here pretty quick. All right, so I'm gonna miss where I was at. We're talking about user. Yeah, we're almost done here. So anyway, and then var will contain things like logs. Anything that changes all the time is what you'll find in var. We've already looked at var log quite a bit. So obviously logs are going to be changing all the time. Anytime you do anything that will trigger a log event, the log will change. As far as, you'll also find mail here. There's a backups directory. There are quite a few different things in there. Also printing. So var spool is something that y'all dealt with for a little bit. While not directly, anything that y'all printed with those printers a couple of weeks ago that did exist in spool for a little bit until the print job was done. All right, so a couple of different concepts that we need to talk about. We're not going to get too terribly far into them. What you really need to know, RAID, right? You've already talked about RAID before. Linear is just a bunch of disks thrown together, right? This is also called JBOD, just a bunch of disks. And really, that's just one big old partition across all of those disks, meaning you just have one big pool of storage. But if one of those disks goes away, then that means that everything on that disk goes away. So by goes away, I mean fails. RAID 0 is striping, so taking two or more disks and making them work together, kind of similar to linear, but if you lose one disk, you lose everything. The benefit there, though, is of speed. RAID 1, mirroring, two disks or an even number of disks, and that means that half your disks have data on them, the other half of the disks have the same exact data on them, and it does this on the fly. RAID 4, 5, and 6 are parity, which means that at least 2/3 of your disks will be used for data itself, and the other third will be used for parity, which if you lose a disk, you can rebuild from that parity. RAID 10 is RAID 1. So you get a set of mirrors, and then you double the amount of disks, and you RAID 0 them as well. So you get mirroring and striping at the same time. So you get the best of both worlds. However, you do lose half your data to the mirror. Multipath is really not a RAID configuration, but it's if you look at the man page for mdatum, which is the software, the configurator that will do all of this RAID stuff for you, you'll see that it talks about multipath, and multipath is really just a way to set up multiple ways to get to a specific resource. So if you have two routes So if you have like a network share and you have two ways to get to that network share, you'll set them up using one of these multipaths, and that means that if one of those pathways dies, that you will be able to get the rest of this. Oop, there we go. Yeah, I was kind of missing some of the live, but it'll be on the video. Anyway, so a faulty device. So you'll also see faulty in that list, and this is just a way to kind of show what happens if you would fault on a disk. So essentially creating errors. And then a container disk allows multiple RAIDs to be used alongside each other. So if you want one big RAID array, but you want multiple types of RAID in them, you can do that as well, and you have to use a container device. So a lot of times you will not necessarily see RAID because there is hardware that can that does most of this for you, and you don't really have to deal with using MDATM to create devices. Any MDATM device is starts with MD, and then 0, and 1, and 2, and 3, and 4. You'll be using LVM. LVM is Logical Volume Manager. Basically what this is very similar, but it allows you to use multiple disks. Those will, in LVM speak, those are called physical volumes, or physical disks, I'm sorry, and that will, from a bunch of physical disks, you will create a volume group, and then from a volume group, you'll create logical partitions. So LV, logical volumes. And what this really allows you to do is create or use multiple disks to create multiple partitions. Or you can, as we did with linear up here in RAID, you can have 5 different disks all in one volume group with one big logical volume across all of them. So this essentially allows it to use multiple disks in a bunch of different ways, really. And you can do striping and mirroring and all kinds of fun stuff with Logical Volume Manager as well. If you are to create an LVM or a logical volume at all, they always show up not in dev directly like you have with MDs and SDA and HDA and all that other fun stuff. It goes into a directory called mapper. So in mapper, you will see the name of your volume group and then the name of your logical volume inside of there. Let's see. I don't think... Nope, those are just basic partitions. So next week we're going to talk about LVM a whole lot more, so stay tuned for that. Just know that if you have a logical volume there in dev mapper, that is a good way to figure out how, whether or not you're using LVM. Another good way, obviously, is something like sudo lv display. I obviously don't have any logical volumes right now, but that's a good way to do that. Or does devmapper exist and is there anything in it? That's another good way to look at devmapper, or look at LVM. And then RAID, if RAIDs exist on the system, then you'll have an MD partition or MD device of some kind. And then you will use MDATM to actually display what's going on there. So anyhow, that's pretty much it. I don't think I really have anything else for you guys. So I'm going to try my best to edit this video to make sure that I don't have the all that craziness that happened in the middle in there. But other than that, if you have any questions, please let me know. I will be around. Hit me on Slack or on email, and we'll get whatever you need figured out. If you need additional help or you need me to show you something or something like that, we can always use WebEx to connect up and make all this work. All right. Well, that's all I got for you. So y'all have a good one.